Hello again from Digicool Things. Ever since creating my existing TMS991 family VDP card, I've thought that I'd also like to play with the TMS's more capable successors, the V9938 and V9958 VDPs, also known as the MSX-Video Display Processors. Where the TMS VDP chip was chosen for the original MSX standard home computers, the success of the MSX standard drove the evolution of the VDP to its much more capable successor, the V9938, which became the display processor of the later MSX2 standard. One of the great things about these MSX2 VDP chips is their backward compatibility. So you can use a V9938 based display card in place of a TMS display card, running the software that was written for the TMS991 family. However, the V9938 also greatly expands on the TMS family's capabilities, offering more display modes and twice the resolution. In addition, the V9938 provides a direct linear RGBS output, meaning that output drivers like the TMS RGB module that I used with the TMS9918 VDP card are no longer required in order to obtain a sharp RGBS output. Furthermore, the colours definitely have more pop when compared to the earlier TMS family display output. So, in summary, you can use the V9938 in place of a TMS VDP and benefit from both better colour and sharp RGBS output with no need for a TMS RGB module. In addition, you have more display modes and twice the resolution to play with. The V9938 was then later further enhanced as the V9958, which added a few more capabilities and featured in the MSX2 Plus computers. This VDP card has all the makings for being my new favourite video display card. So let's get started. Here is the schematic for my new VDP display card. As you can see, it contains the usual MECB ATF16V8 PLD chip for the glue logic, then the 64-pin VDP chip itself. In addition, we have four 4464 dynamic RAMs to provide 128 kilobytes of VRAM. Finally, we have the output drivers to deliver the RGBS output via the same mini-DIN Sega Mega Drive compatible connector that I used on my earlier TMS VDP card. In addition, I have the same audio pass-through connection to allow also delivering the audio output via the same mini-DIN cable. So a nice clean design, and as mentioned before, no need for a TMS RGB module like on the TMS VDP card in order to obtain a sharp RGB plus sync output. So next, here is the 3D render of my newly routed MECB V9938 or V9958 VDP Display Card. The PCBs were ordered and have now arrived. So, on my workbench, you can see that I've laid out all of the component packs, except for the VDP chip itself, to enable building my V9938 or V9958 VDP Display Card. In addition, I need four 4464 64K x4 dynamic RAM chips and some IC sockets. So let's get one assembled so we can try it out. And here's how it looks all soldered together. Now this is where things got a bit tricky and significantly delayed my completion of this project. The problem was the difficulty obtaining the prized VDP chips. I actually spent several $100s sourcing V9959 chips from various suppliers. I'll show you them. Let's move the board out of the way. And 1, 2, 3, 4, 5, 6, 7, 8, 9. The problem is they are all non-operational fakes. In retrospect, there was a couple of obvious clues that should have given them away. Firstly, the genuine V9959 chips do not have the usual notch in the end to indicate pin 1. Secondly, the date code of 1901 was a bit questionable for a chip that was released in 1988. Unfortunately, I was also unsuccessful trying to get refunds for any of the fake chips. Even with these seemingly obvious clues, in testing of the chip showing no activity, including no clock signal from the pin 8 clock output, which should provide a 3.579 MHz clock output for the CPU, they insisted I make a video that proved the chips were not working. Given the illogical suggestion of making a video to prove that something isn't working, as opposed to a video proving something is working, and that I didn't yet have a working chip to show my display card was actually working, I ran out of time to successfully get my money back. But never mind. These are the frustrations we sometimes go through in our endeavour to explore retro out-of-production devices. So, next, I happen to have a couple of faulty Sony devices, which I'd obtained a few years earlier, knowing that they contained these prized later generation 64-pin VDP chips. So here is a photo of the inside of my faulty Sony My First Computer TV animation computer. The initial fault in this device was clearly a bunch of leaky electrolytic capacitors, which were also corroding the PCB traces. I did think about a repair, but at the end of the day it was just the V9938 chip I wanted to play with on my MECB platform. Here is a photo I took of the video output of the Sony computer. Obviously some problems with the video output circuitry, but enough to show me that the VDP chip appeared to still be working. So I carefully desoldered the 64-pin IC. I had thought of perhaps installing an IC socket in its place, but unfortunately getting the chip out successfully involved destroying a few PCB pads and PCB traces. With my recovered V9938 chip cleaned up, I was at last able to test my new VDP display card. The first test was simply to use it directly in place of my existing TMS VDP card with my 6502 Creative Vision Recreation project. With the backward compatibility of the V9938, I should be able to simply insert the same PLD chip and just swap out the display card. And all going well, it should just work with the existing Creative Vision TMS VDP targeted software. An easy first test of the new display card in operation. So, let's get rid of these fake chips. In fact, one of them I even scrubbing with acetone, just to see if I could see what was underneath the chip, underneath the fake markings. Unfortunately, with lots of scrubbing, what I came up with was the same markings underneath. So, let's get rid of these. Okay, here's my recovered 9938 chip. And we'll get our circuit board. So first I might install the dynamic RAM. Right, so now I'll insert my recovered V9938 VDP chip. Noting the pin 1 indicator is the indent. There's no notch on these chips. Next, I'll insert a couple of my PCB standoffs just into the end, because I'll mount the card horizontally in the back plane. Right, next I'll pull out my existing TMS card. And I'll swap across the PLD to the new card, because the same PLD should work. And finally, I'll plug the new card back into the MECB backplane and attach the video output. So, with the new card in place, let's turn on my 6502 Creative Vision Recreation. And I get a nice sharp display of Sonic Invaders, with even more colour pop than the original TMS display card produced. Here's a side-by-side comparison, captured with my video camera set with the same manual settings. In person, the first thing that jumped out were the bolder blues and also the nice red explosions and red mothership. So, with the new display card operating as expected, in pure backward compatibility mode, the next step is to swap out for my 689 CPU card and write some code to test at least one of the enhanced modes available with the new VDP chip. So I'll turn that off. Let's pull all of the cards out of my MECB backplane. Here's the VDP card. We won't need the ROM expansion card. There's the 6502 CPU card, which we also won't need. And this is our MECB Motorola I/O card. Now, first thing I'll do, I'll get rid of the old TMS display card. For the new card, I'll insert the standard VDP I/O 80 to 87 PLD chip. So let's take out the Creative Vision VDP PLD. And I'll insert the general VDP I/O port 80 to 87 PLD. Likewise, for the Motorola I/O card, I'll take out the Creative Vision PLD and swap it for the standard I/O port 0 to 17 PLD. We also won't need our Creator Vision controller. So we'll get rid of that. Plug our ground pin back in for the serial interface. Let's put the I/O card back in. So next we'll need my 6809 CPU card, which is currently set up with a SysO9 and 48K RAM, 16K ROM, and the I/O bank at C000. Let's insert that. And finally, let's put our new V9938 VDP card back into the backplane. We should be all ready to go. So we don't need these two jumpers because they were for the V9958. With the V9938, we just leave the jumpers out. So I'll just reconnect the serial port. Fire up TerraTerm and I'll switch on. So we get a SysO9 monitor prompt. So now I can create a simple Hello World test program that tests the original 40 by 24 character text mode of the TMS VDP. So let's take a look at that. Okay, so here's the 6809 assembly source code for testing the normal text mode, which works on either the TMS or the V9938 VDP. I edit my assembly source code in Visual Studio Code Editor. So you can see, to start we have the header, which just explains it's a simple 6809 CPU card test for either the TMS or the V9938 or 58 VDP card. I've got it RAM loadable 0100 entry, and I've defaulted the VDP to be at address C080. So with the I/O bank set to C0 and the VDP address to code is based on the I/O request range of 80 to 87. So you can see I've got a few equates, one for the entry address, one for the VDP address, and from that I calculate the VDP VRAM address, which is the same as the VDP address, and the VDP register address, which is the VDP address plus 1. Then we have our main entry point, which is currently at 0100. So initially I just do some standard 6809 initialization by setting the direct page register to 0, even though we're not using it, and also tell the assembler which page the DP register is set to. Okay, let's scroll up. Then I set up the VDP initial settings by loading X with a pointer to where my initial register values are, and then I branch to a subroutine to transfer all these VDP registers. Then I clear and set up the VDP RAM by jumping to a subroutine to clear the RAM, and then jumping to a subroutine to set it up. And finally I just simply set register 1, the relevant bit, to turn on the VDP display. And then I return from subroutine, which will exit the program back to the SysO9 monitor. So then we have a few subroutines. I've got a subroutine to set the VRAM read address and another one to set the VRAM write address, and a subroutine to write a register, subroutine to read a status byte, which we don't use, and a subroutine to read a VRAM byte, and a subroutine to write a VRAM byte, which again we don't use because they simply involve loading the accumulator from the VRAM address and storing an accumulator at the VRAM address. So the first main subroutine we call is to transfer all the VDP registers. So on the original TMS there's only 8 registers, So this routine just simply writes out the 8 registers to the VDP. Then I have another subroutine which simply sends a static byte to the VRAM for a number of bytes. And another subroutine which is similar, but it takes the original byte and increments it as it's writing the bytes. Then a subroutine to transfer a VRAM block. So this writes a block of bytes to the VRAM, which register X is pointing to, and register Y contains the count of bytes to transfer. Then I have a subroutine to clear the VRAM, which at the moment just clears the full 16 kilobytes that the TMS VDP has. It does that by setting the VRAM write address using that subroutine to write to address 0, and then I load Y with 16K and call the subroutine to set the VRAM block, which writes the A accumulator value, which I've cleared, to 16K of VRAM starting at address 0. And I have the VRAM setup subroutine, which starts off by copying my 128 byte font, which is 1024 bytes of 128 8x8 character patterns, into the VDP's pattern table, which starts at 0800 in the VRAM. Then, because we're using text mode, I clear by writing a space character to all 960 screen locations. It's 40 by 24 display. Then I display a message I've defined below, message 1. And then I display the font, which is in fact all 128 characters. That gets copied across to the name table using the increment VRAM block. So basically I'm starting off with character 0 and then incrementing all the way through to character 127. And I display message 2, which is defined below. And that's it. That's all commented out. So that ends the subroutines. And then I've got the 8 registers of their initial settings, which are transferred above. This defines the text mode and the start address of the name table, the color table, pattern table, etc. As well as the text being white on a blue background. Currently I have commented out the dark green text on a black background. Then I have message 1, which was simply to show the width of the screen by showing 01 through to 40. Message 2 is hello world. And then we have our font pattern, which is 128 characters of 8 bits by 8 bits. So 8 bytes per character, which is the rest of the listing. Rightio. That's our original VDP test program for the original text mode, which is available in the TMS VDP and also available in the V9938 and 58 through backward compatibility. So let's give that a try. So with the 40 column Hello World program assembled and transferred to provide a Hello World test in the original TMS text mode. This enabled me to first use the original TMS VDP card to make sure my code was working properly. The program worked perfectly on my TMS VDP card. So now I can run it on the V9938 and check we are still getting a successful Hello World display. Note that I also loaded up a 128 character font for the test, noting that the VDP is capable of defining 256 characters for its font when in text mode. The background and character color is also selectable. I tried both a normal retro green screen, but I ended up using a white character on a blue background. as I thought this looked really nice and it also captured better with my camera. So here's the Hello World 40 column test running on the new VDP card. So far we're looking good for the new display card running in backward compatibility mode, replacing the old TMS VDP card. Now, one of the new modes supported by the double resolution capabilities of the V9938 is the Text 2 mode, which now provides a full 80 by 24 character display and also supports blinking characters in different colours. So I modified the Hello World test program for testing this new Text 2 mode, which will only work on the new V9939 VDP card. So let's have a look at that code. So this is my Text Mode 2 program, which will only work with the V9938 or 58 VDP. It's not available on the original TMS VDP, as it does 80 column text. So let's have a look what's different. The header is all pretty much the same. I make the same calls. I'm initializing registers 0 to 23 instead of 0 to 7. There's actually 45 registers on this new VDP, but I'm just initializing the first 23. And I have the same subroutine calls as the earlier text mode program. So the differences are, for the new VDP, when I set the VRAM read address and the VRAM write address, I now actually set register 45, which selects between the VRAM bank of RAM, that's 128 kilobytes, or the expansion RAM, which is another 64K that's available, but I haven't implemented on the VDP card. Then we write to register 14, which is the high 2 bits of the VRAM address. And the rest of the subroutine is the same as for the TMS, when we simply store the low byte of the address and what is now the middle byte of the address. Same for VRAM write address. Nothing changed in writing to a register. Status isn't used, and these aren't used and are all unchanged. For transferring all VDP registers, I now write a block of 24 bytes to the VDP registers instead of the block of 8, the previous program. These subroutines are all the same. The VRAM clear, I'm still clearing 16 kilobytes, so only the bottom of the VRAM I'm clearing because we don't use the rest for the text. VRAM setup is similar. I now write a space character to 1920 screen locations for the 80 by 24. Display message 1, display the font, display message 2, and I clear the color table for possible 270 screen locations because the VDP is actually capable of doing 80 by 26. Now the reason I clear the color table is because one of the advanced features of the V9938 VDP is it now uses the color table in text mode for an attribute bit for each character, which determines the flashing or non-flashing mode of the character. When it's flashing, it also uses a different color register, so you can actually flash it in a different color as well. And that's basically it. We have our initial registers, 24 registers. And I've just put a brief comment there to indicate what the primary reason of that command register is. You can refer to the V9938 programming manual for more information. Message 1 I've expanded to now be 80 columns wide. So I've got 0 to 40 and then 41 to 80. And we have an 80 column Hello World message. And the same font as we saw in the last program. So that's it. So as you saw, the V9938 now provides 45 command registers, as compared to the TMS, which only has 8 command registers. So with the text-to mode code assembled and transferred across to the CPU card, here's what it looks like. Nice, we now have 80 column text capability. So with this test done, I'm happy to call my new VDP card a success, and definitely my new favourite VDP card to play with, as there are many more modes that I need to explore. I'll put the source code for these 2 new tests on the Digicool Things MECB GitHub repository, as normal, along with the PLD source and compiled .ged files for easy programming. Now the really good news. After trying a few suppliers for genuine original V9938 and V9958 chips, I now have a trusted source. Let's move these out of the way. And here is my current stock. Of VDPs. All tested, 100% working. Aside from my self-recovered original V9938 chips, the rest were all new and original chips. I even had to bend the legs slightly to get them into the card's IC socket for testing. I also have one verified and more expensive to obtain V9958 chip. This also enabled me to verify the new VDP display card with its 2 jumpers in place for V9958 support. All worked as expected. However, at this stage the V9938 is cheaper and has plenty more modes than the old TMS family chips to experiment with. So I've decided that in order to support other enthusiasts who are also interested in playing with this awesome VDP chip, that I'd add an optional pack to my Tindie Store for these pre-tested VDP chips. I don't suspect I'll ever recover the money I've lost with all the fake chips that I bought, but if you are keen to try out my new MECB V9938 or V9958 VDP card, then you can support me by also buying a pre-tested and verified VDP chip from me. So that's all for the introduction of my awesome new MSX-Video VDP Display Card, which gives a lot more to experiment with. If you enjoyed this video, please like and subscribe with notifications to be alerted to future videos. Have fun. That's it. Thanks for watching.